Rational equations. We'll start with easy and then work our way up to as hard as they are probably going to get. We'll start with super easy, like 7th grade easy. This is technically a rational equation. You've done that kind of equation before. It's a fraction on each side. We called them proportions back when we were doing that in Algebra 1. How do you solve proportions? Cross multiply. That's the name of the game. So if you have one fraction on the left side, one fraction on the right side, you can always do that same skill that you already know and cross multiply. 8 times 6, 11 times 3x, so that's 33x is equal to 48. And then get x by itself. So divide by 33. 48 and 33 both divisible by 3. 3 goes into 33 11 times and into 48 16 times. And there we have a solution to that. This one has no excluded values. The reason it has no excluded values is because the original problem doesn't have any variables in the bottom, in the denominator. Okay, if you got variables in the denominator, we got to look at excluded values. This one doesn't have any because the x was in the numerator only. So there's no rule saying you can't have a certain number in the numerator. When we have variables in the denominator, we got to take care of what if that turns out to be 0 in the denominator. So that's where the excluded values come in. So if there are variables in the denominators, you got to deal with excluded values. If there are not any variables in the denominator, you don't have to deal with excluded values. So super easy, almost too easy to do in Algebra 2. So let's do something a little bit more difficult. But still, I would say this is Algebra 1 level. This is probably like, one of the problems that I did with my Algebra 1 group in the fall when we were doing proportions. Okay. So the first thing you should notice with this one is the denominators have what in them? Variables. So what we've got to take care of are excluded values. What are the values that x cannot be? And the thing that you've got to look at is those denominators. And if it's a proportion like this, where you have a fraction on each side, the easiest thing to do to get your excluded values is just set excluded values. Set those denominators equal to 0 and solve. So x plus 1 equals 0, 4x plus 5 equals 0. And just solve them. So we know x can't be -1. We know x cannot be -5/4. If we get one of those as an answer when we solve this, we know we throw it out. That it cannot be an answer, because if I plug in -1 on this one, I get -1 plus 1 is 0, and the only number in the world I can't divide by is 0. So that is the reason -1 is an excluded value. Excluded value for this one is -5/4. So if I plug that in here, I'm going to get 0 in the denominator, and I cannot divide by 0. So that's where the excluded values come in. You've got variables in the denominators, that's what's going to happen. So because it's one fraction equal to one other fraction, the easiest way to solve this, not the only way, but the easiest way is to just cross multiply. 9 times x plus 1, 3 times 4x plus 5. And it doesn't matter which side you put either of those on. It's just got to be those same pieces.
Tyler Lippert, report to the office. Tyler Lippert.
And then we just do distributive property and get x by itself. So 9x plus 9, 12x plus 15. And do the math to make it work. I'm doing it this direction, doesn't necessarily matter. The 6 divide. X is -2. That doesn't match one of the excluded values, so we're going to keep it as a solution. Okay. If it were to match one of your excluded values, you just know you mark it out. It's what's called an extraneous solution. Okay. So pretty easy ones there, the first two, where you're not having to do a ton of math there. Now, that's not the only way to do those kind of problems. But if it's one fraction equal to one fraction, that is absolutely the easiest way to do them. And that's what I would recommend that you do, just because it's easier and quicker. All right. Let's look at another one that is somewhat easy, but a little bit more difficult. Let's say we had 1 over 2x plus 5 is equal to x over 11x plus 8. I see x is in the denominator, so I got to deal with excluded values. So you want to find those first before you start working to solve this. So what do I do to find those excluded values again? Yeah, set the denominator is equal to 0. So 2x plus 5 equals 0. 11x plus 8 equals 0. And solve those for x. We know our excluded values are negative 5 over 2 and negative 8 over 11. If we get one of those as an answer, we know we're going to throw it out. Now, is this a proportion? Meaning one fraction equal to one fraction? Yes. So we're going to do it the easy way for proportions and just cross multiply. Well, on one side, it's 1 times 11 plus 8, so that's just going to be 11x plus 8. On the other side, it's x times 2x plus 5. Maybe I'll just go ahead and write that 1. We're going to distribute on both sides there. So that's going to give me 11x plus 8. On the other side, I get 2x squared plus 5x. Now, this is a little bit more difficult equation to solve than the last one we did because it has an x squared in it. So that should trigger all of the things we know about solving quadratics. If we're going to solve a quadratic, what do we need to do? Get it equal to 0, absolutely, because that opens up the opportunities to either do factoring or quadratic formula. Either which ways for this one will work, but quadratic formula always works. So we want to get it equal to 0. So I'm just going to move the 11x and the 8 by subtraction. There's 0 equals 2x squared minus 6x minus 8. What do we want to do now? Yeah, GCF of a 2. If we can pull that out, that'd be nice. X squared minus 3x minus 4. And then technically, this is what happens with that 2 because it doesn't have a variable. You know, we cancel it out. That's what happens. Just get the x squared minus 3x minus 4 is equal to 0. And then you've got to make a choice. Which way do I want to solve that? Do I want to factor it or use quadratic formula? I don't care which way you do it. This one works with either. I'm a factoring person, especially when the numbers are this small. And you know, I'm thinking, what multiplies to be negative 4 and has to be negative 3? Negative 4 and 1, right? So that makes the factors x minus 4, x plus 1. We do what with those? Set them equal to 0 and solve. X equals 4, x equals negative 1. Neither of which match an excluded value, so we're going to keep both of them. You could check them in the original problem, make sure they work. They do for this one. But we're going to keep both of them because they don't match an excluded value. Now that. Anytime you have an exponent on the variable, when you go to solve your equation, you know you got to get it equal to 0 to do that. Okay, so if it's squared, cubed, anything like that, you know you get it equal to 0 and use the skills that we've learned in order to solve that equation. All right, so one fraction equal to one fraction, we're going to cross multiply and solve. That's the easiest way to solve those, and the way most mathematicians would do it because it's simple. Let's look at what if it's not just one fraction on each side. Maybe there's more than one fraction on one of the sides. So let's take this example. 5 over x plus 7 over 4 equals negative 9 over x. So here we have a fairly simple one, but it does have two fractions on one side and one fraction on the other. And there's a couple of different ways to do this. The way I want to show you is kind of a generic thing that's going to work for all things. This one could be done a little differently because the denominators are the same. But I'm going to work at this one the way that we're going to work at most of the rest of them that we're going to see today. So let's find a least common denominator because we got different denominators in all the fractions here. So what would be the least common denominator between an x and a 4 and an x? 4x. So what does the first fraction need? 4. So I multiply the bottom by 4 and the top by 4. What does the second fraction need? X. So I multiply bottom and top by x. The third fraction needs 4. So I multiply bottom and top by 4. So that's going to give me 20 over 4x plus 7x over 4x is equal to negative 36 over 4x. Once you get the denominator, the least common denominator, then you can find your excluded values. All you've got to do to get excluded values is take the least common denominator and set it equal to 0 and solve. So excluded values come from the common denominator set equal to 0 and solved. Okay. In the first 3 examples that we did, we didn't try to find a common denominator because there were just 2 different denominators, and we set both of them equal to 0 and solved to get the excluded values. So that's really what we're doing here. We're just using the LCD here because it's, that's what we're finding to do the math. So that's what we're going to try to remember is least common denominator, set it equal to 0. That one's easy. We know x can't be 0. If x equals 0, we're going to throw it out. Okay. So now you've got a problem where it's very easy. Once you get the denominators the same, all you've got to do is just drop the denominators and deal with the numerator equation. Because the denominators are all the same, then the top parts should work out, right? This 20 plus 7x should be equal to negative 36 when we work that out. Okay, so get the denominator the same, fix all the fractions, and then drop the denominators and just do the numerator equation. 20 plus 7x is equal to negative 36. Do I need to get this one equal to 0? No, there's not an exponent on that x that's bigger than 1. It's technically a 1 exponent, but so you don't need to get it equal to 0. Just get x by itself. So real simple math here. 7x is equal to negative 56. That works out nice. X is negative 8. And it doesn't match my excluded value, so I'm going to keep it. So my answer is x equals negative 8 out of that. Not incredibly difficult there. Pretty easy one to start off with. All right, let's look at one that's a little tougher. 1 minus 8 over x minus 5 is equal to 3 over x. Okay, so first thing I want to see here is that I've got 2 different things on one side and 1 fraction on the other side. So that tells me I can't do the cross multiplying. I've got to do least common denominator for that because I have 2 things on one side, 1 thing on the other. So I need to find the least common denominator. Well, 1, technically the denominator is 1. So I'm just going to just put that there so we know for sure. What would be the common denominator between a 1, an x minus 5, and an x? What? X and x minus 5. Because remember, this x minus 5 is a separate thing. It's because you're dealing with factors. X minus 5 is a separate factor from plain x. They don't share that because they're not multiplied together. Factors have to be multiplied together. So technically, there's a 1 in front of that x that's out in front. So technically, there's a 1 there as well. But it's just the product of those. So the first fraction needs what? Both of those. So I'm going to multiply it by x minus 5 on top and bottom. X minus 5. What does the second fraction need? x. So multiply bottom and top by x. Third fraction needs x minus 5s, top and bottom. Now I'm just going to fix the fraction. So I have x minus 5 over that common denominator minus 8x over x minus 5 is equal to 3 parentheses x minus 5 over x minus 5. I've got the common denominator done. I can find my excluded values. Set the least common denominator equal to 0. And set each factor equal to 0. So x can't be 0. X cannot be 5. Excluded values should be one of the easier things. If you can get a common denominator, it is real easy. Okay. Next thing to do, because we have the denominators the same now, is do what with them? Get rid of them. Don't worry about them. Just do the top part. X minus 5 minus 8x is equal to 3 x minus 5. Now, you may have already distributed there at that step. I don't care when you do that. You've got to do it at some point. You may already have it as x squared minus 5x minus 8x equals 3x minus 15. Maybe you already do. If you don't, get it there. And then what do we need to do? To do that, we need to do what? Get it equal to 0. So I'm just going to move this stuff. And I know I've got some like terms already over there on the left. Minus 3x and then plus 15. There's my equal to 0. So I have x squared. I've got a negative 5, a negative 3, and a negative 8x. So that's going to be negative 16x plus 15. And then we have to choose whether we're going to do factoring or quadratic formula. I don't care which way you do that. Do we know anything that multiplies to be 15 and adds to be negative 16? Yeah, negative 15, negative 1. If you know the numbers that quickly, factoring is probably your best bet. If you can't think of them really fast, just jump on into quadratic formula. And you're going to get the same answers even if it would have factored. So this would be x minus 15, x minus 1. We set each of those equal to 0. And we get solutions of x equals 15 and x equals 1. Neither of which match an excluded value. So we don't have to throw one of them. We're going to keep both of those as answers. Both of those would satisfy that original equation. We plug them in there. So not too difficult. We're just dealing with some easy stuff so far. All right. Let's look at the next one. Go a little bit more difficult with this one. 6 over x minus 3 is equal to 8x squared over x squared minus 9 minus 4x over x plus 3. All right. This one's a little bit more difficult. Not terribly difficult, but it's a little bit more. What do we notice about the denominators? Or maybe one of them in particular. We got an x squared minus 9. We know that factors. Anytime we're dealing with fractions, adding, subtracting them, or equations, we want to think about if the denominator will factor, we want to factor that. So x squared minus 9 we know is x plus 3 and x minus 3, which is nice because, hey, we got an x minus 3 over here. We got an x plus 3 over there. So it matches up with some stuff. So that's going to help us when we find that least common denominator. Well, what's shared? Now, the x minus 3 is shared with the left one and the middle one, and then the x plus 3 is shared with the middle one and the right one. So is there anything that one of them has that that doesn't cover? No, because this one is factored as that, then that's going to match up. Okay, so our least common denominator is x minus 3 and x plus 3, whatever order you want to write that in. Now, what does the first fraction need? It needs an x plus 3 on top and bottom. Does the second fraction need anything? No, that's a good thing. We don't have to do anything to that one. Third fraction needs the x minus 3 part. Okay, so we have 6 parentheses x plus 3 over that common denominator, x plus 3, x minus 3. And then that's equal to 8x squared over x plus 3, x minus 3, minus 4x parentheses x minus 3 over x plus 3, x minus 3. Now, obviously, you guys, some of you are saying, do I have to write that step because I know what's going to happen next? No, you don't. Okay, take those shortcuts when you can because it's a long process anyway. But don't forget to find what? Over on the side, you need to find those excluded values. Don't forget those. On EOC, they call them excluded values, but they also can say restrictions on the domain. They're the same thing. They're synonyms with one another. So excluded values, if you see restricted values or restrictions on the domain, that means the same thing. What's the denominator problem here? So x plus 3, x minus 3. Set that equal to 0. So we're setting the common denominator equal to 0 and just solving. Should be real easy stuff. Negative 3, positive 3. Can't be those. If it is, we're going to throw them out. Okay. The equation that we're going to work on is just the numerator equation. So we got 6x plus 18 equals 8x squared minus 4x squared plus 12x. Notice when I distributed the 4x, I distributed the minus sign with it. Right? That's how I got the plus 12x there. All right. I'm going to simplify a little bit. Make that 4x squared plus 12x. And this is 6x plus 18 still. Do I get this one equal to 0 or just get x by itself? Why do I have to get it equal to 0? It's quadratic. It's got an x squared in it. That's why I know to do that. So do the work. So I'm just going to subtract 6x and 18. There's my 0, 4x squared plus 6x minus 18. What do we know about those? Yeah, take out our 2. So I'm just going to divide them all by 2. Get 2x squared plus 3x minus 9. Two times negative 9 is negative 18. Do we know anything that multiplies to be negative 18 has to be 3 real quick? 6 and negative 3 does that. So factoring would be a good option here. Again, remember, quadratic formula is going to work as well to get you the same answers. Negative 3 and 6. So I can't do the shortcut on factoring. I got to go the long way because it's got the number in front. And then group. So that's going to be 2x, x plus 3, minus 3, x plus 3. So my factors are 2x minus 3. Things I'm setting equal to 0, and then x plus 3. Nice in parentheses. So I have 2x minus 3 equals 0, x plus 3 equals 0. 3 over 2, negative 3. But what do we know about negative 3? It's one of our excluded values, so we're just going to throw that one out. So just put an X through it like that, where I can still see it's there, that you found it, But because it's an excluded value, you're going to throw it out. So the only real answer to this is 3 over 2 for this problem, even though we found 2 of them. All right. Not incredibly hard here. It's just, again, if you can add and subtract fractions, the equations are not hard at all, actually. Okay. Let's do one that's a little tougher. Last one, and then I'll let you work. So, 1 over 3x plus 9 plus 1 over 3x squared plus 15x plus 18 is equal to 1/3. A lot of ones. Which makes the numerators nice, but the denominators are not too friendly. This one. So, first thing we see is we got 2 fractions on one side, 1 fraction on the other. That tells me that I need to find what first? LCD, the common denominator. Got to find that before I do anything because I don't have the nice trick where I can cross multiply. Always look for the cross multiplying if possible. Okay. Now, what do I know about the denominators of these fractions? Will any of them factor? Okay, which ones? First one, it's got a GCF of the 3. So it's 3x plus 3 is technically what the first fraction has. I can pull a 3 out of the second one. Not 15, but 5. Will that x squared plus 5x plus 6 factor? Yeah, it factors as x plus 3, x plus 2. And then obviously the third one doesn't factor. There's the number 3 there. Now, so the least common denominator, what do they all share? A 3. And then what factor is shared between 2 of them? X plus 3. And then what's the lonely guy that's not x plus 2? It's got to be part of it too, because it was there. So that's our common denominator. Happens to be what the second fraction factored as. That doesn't always happen that way, but it does on this one. That helps us a little bit. Okay. So what does the first fraction need? It needs the x plus 2. So bottom and top get x plus 2. Does the second fraction need anything? No, it's got everything that's in the common denominator is in the denominator of that fraction. So I'm not going to do anything to the second one. The third one needs what? Yeah, it needs the x plus 3 and the x plus 2. And we're going to... Let's get our excluded values before we run out of room here.